Hi, hello, my name is Alan Epsamonte, and today we're going to be talking about dividing radical expression. So when dividing a radical expression, we use the quotient rule. So what is quotient rule? A quotient is the answer to a division problem. When dividing a radical expression, we use the quotient rule to help solve them. The quotient rule states that a radical involving a quotient is equal to the quotients of two radicals. So let me show you what does that mean. It means by this: n squared of a over b is equals to n squared of a over n squared of b. As what I said, quotient rule states that a radical involving a quotient is equal to the quotient of two radicals. This is the two radicals. So when you divide one radical expression by another, you can simplify it by writing both expressions under the same radical, then simplifying. The quotient rule works only if, number 1, each radical has the same index. The index is the superscript number to the left of the radical symbol, which indicates the degree of the radical. For example, cube root of 27. Also remember that this 3 is your index, or that cube is your index. So how are we gonna solve this? Let's say 27 is 3 cubes. Cube root of 3 cube. Then after that, we're gonna cancel this both, cube root and raised to cube. So let's cancel this both. And you have your final answer, 3. So in this example, the index is the 3. This one. And it is indicating the cube root of 27. If there is no index, it is understood to be 2 or square root. And second, the denominator of the fraction is not 0, which I mean you cannot have a quotient rule, like for example a over 0. That's a no. We cannot solve quotient rule if we have 0 as our denominator, because if we have a number in our denominator, it's a yes. So that is quotient rule. So we have 5 steps for dividing radical expression. 1 is ensure that the index of each radical is the same and that the denominator is not 0. Second, convert the expression to one radical. Third is simplify where possible. And fourth, rationalize the denominator if necessary. For example, square root of 100 over square root of 4. Once we have determined that both the numerator and denominator have the same index of 2 or square root and that denominator is not 0, we can use the quotient rule to convert the expression to this: square root of 100 over 4. Solving under the radical 100 over 4 is 25, which also give us square root of 25. Because of course we're not gonna forget square root. And then after that, we're gonna solve it again, which square root of 25 is 5, since there is no denominator to rationalize. And that's it. That's the answer, 5. So the last step in simplifying any radical expression with a factor is to make sure that there is no radical in the denominator. This is called rationalizing the denominator. To rationalize a denominator, you multiply the expression by an appropriate fraction that is equivalent to 1. For example, square root of 5 over square root of x. Because there is a radical in the denominator of this expression, we need to rationalize the denominator to simplify the expression. The first step is to create a fraction that is equivalent to 1 that will help remove the radical from the denominator. Most of the time, the fraction needed will be the same as the radical in the denominator. To make it a fraction that is equivalent to 1, you must have the same numerator as denominator. For example, the first step is square root of 5 over square root of x times square root of x over square root of x. So how are we gonna solve it? So the problem looks like this. Square root of 5 times square root of x over square root of 5 times square root of x. And after that, you're gonna times them both. You'll have square root of 5 times x and square root over square root of 5 over square root of x times x. Wait, there. Because the square root of x raised to 2 is equals to x, the radical is removed from the denominator, and the simplification of this expression is, let's put it here, excuse me, square root of 5x over x. And that is our final answer. That's it. That's all. That's everything. Thank you for watching, and I hope you understand the lesson dividing radical expression. Bye-bye.